In this video I'm going to explain how I forge a Western style katana sword. There is a lot of discussion online about Western smiths using wrong methods forging Japanese swords and naming them katana swords or samurai swords like I do. I have to admit I do this to generate discussion, and it works. I have great respect for all cultural heritage, from Asia, Africa and Scandinavia, to mention a few places. But I use modern day methods to create swords. For this sword I am making pattern welded layered steel. Two steels are used to create a good contrast. One is 1075 and one is 15N20 steel. One of the steels contains nickel, making it harder to corrode in the acid, creating a good pattern. I forge weld the billet 4 times, stacking and welding it over and over again. Borax is used to seal the steel from air, making for cleaner welds. Oxidation by air or even burning will cause delamination or overall complete failure. I have seen Japanese smiths using borax, but most of the time the silica residue from the steel making process is enough. That's right, sand can be used as a flux, creating a layer of molten glass, but borax works way cleaner. I have to clean the surface at every step. A historically correct way would be to forge in charcoal, generating a very clean oxygen-low environment, using water on the anvil to clear out surface scale. In this way hot cutting is possible, but as I said, I am using the modern day approach. The billet parts get welded by MIG. The welds will be cut off in a later stage. The borax is very aggressive on the forge. I have to refurbish it once every 2 years. The forge is lined with an isolating blanket and shielded with refractory concrete. The forge can go up to 1500 degrees Celsius. 1200 degrees Celsius is needed to forge weld. The melting point of steel is somewhere around 1500 degrees, but this depends on the steel alloy. If the melting point is reached, it will completely ruin the billet. After this process that takes around a day, a layer count of 420 to 800 is reached. Anything higher is not that visible anymore as the steel gets to blend. The steel gets surface drilled. This process cuts through the superficial layers, creating a teardrop pattern. I completely deform the steel after, as I prefer to forge to shape, making it more of a wild pattern. The fuller is pressed in. This method saves steel and is also making the pattern more vivid. A big katana is historically a relatively heavy blade. I really like heavy and big swords. I aim for a weight between 1 and 1.8 kilograms for the total sword. The grinding is done by machine. The correct way would be using steel scrapers. The steel is etched. This is a preview etch, as the sword still has to be heat treated. Iron wire is used to get some sort of grit to hold fast the gun gum in the heat treat. Gun gum is used. This heat-resistant clay-like substance is placed on the spine to create the differential heat treatment. The back of the sword stays soft, but the edge is hardened. A pattern can be made, and even birds or waves can be drawn. This uneven pattern heightens the chance of the blade chipping instead of breaking when critical failure would happen, giving the user still a fighting chance. A metal strip is used to heat up the oil. This oil is a very fast oil, around the same speed as water, but less likely to cause the sword to break or warp. Preheating the oil also helps evening out the initial shock. The blade has to be around critical temperature, red hot, preferably an even red. The hardening temperature completely depends on the steel type, also the chance of creating a Hammond or hardening line. After hardening, the blade is placed in an oven to temper it, loosening the steel crystal structure a bit, releasing uncomfortably trapped carbon molecules. This process helps a lot in making the blade tougher, but some hardness is lost. After the temper, a fire temper is done, further relaxing the blade. Corrections to the blade can be made now, but only when it's hot. The sword is grinded, polished and etched. After the etch, a hammer line is clearly visible, but with pattern welded steel, a hammer is not that prominent, as alloy steels tend to harden differently. So far my explanation. A lot more can be said about the process. Let me know what you think and if you like this kind of video. I am willing to put in the work if there is an audience for it.